Today we're going to review looking at logarithms, and let's start with the warm-up. Can you identify each as a power function or an exponential? So the key is look at the exponent. If the exponent is a number, it's a power function, and you solve by doing opposite order of operations. If the exponent is, if the exponent is a variable, then this is an exponential function, and you're going to use a logarithm or guess and check or common base to solve. This one right here, remember, if it's just a log, the common base is 10. Let's write in exponential form. This is 10 to the x power equals 12. So they want to know 10 to what power is 12. This is exponential. So you do have to know the difference between power and exponential, because exponential we're going to solve using logarithms. So let's do a quick review. Simplifying exponents is something that we did earlier this chapter. To do that, if there's division, look at the different bases. Let's start with the numbers. 32 divided by 8 is 4. Then look at the a's. There's 5 on top and 9 on bottom. So think to yourself, when you cancel, how many are left and where? And if you cancel 5 a's from top and bottom, there's 4 a's left on the bottom. If there's 7 b's on top and 2 b's on the bottom, if you cancel, there's 5 left on the top. So here's the simplified version. When you see the parentheses raised to a power, do the inside first. So here we have 4 over 6 is the same as 2/3. We have 8 a's on top and 1 on bottom, so we have 7 a's left on top. And we have 2 b's on top, 9 on the bottom. So if you cancel 2 from top and bottom, you have 7 on the bottom. All right, a power to a power means you're going to distribute to all the bases. So we get 2 squared, a to the 14th, over 3 squared, a to the 14th. Then we simplify, we get 4 over 9, a to the 14th, b to the 14th. And the last one, let's simplify the inside first. You know that if you have negative exponents, you can flip them and make them positive. So b to the negative 5 is the same as b to the positive 5 if you flip it to the top. And a to the negative 3 becomes a to the 3rd power on the bottom. This is squared. So you're going to take that exponent, you're going to distribute. So we're going to have b to the 10th power over a to the 6th power. So that's a review. We're going to go now to examples of solving with logs, 2 more examples from what we did yesterday. In 2000, the population of St. Louis Park was 33,685. The growth rate is 3.3% per year. When did the population reach 45,561? Let's write an equation. So we have y equals our starting value. It's growing at 3% a year. When did the population reach 45,561? First step, get the base and the exponent by itself by dividing. Divide each side by 33,685. Oops. All right, so we have 45,561 divided by 33,685. Okay, so that answer is about 1.32, 1.35. Right, I'm going to find a common base, or not find a common base, we're going to use a logarithm to solve. The base is 1.033 of 1.35, and that equals x. Type that in your calculator and it'll tell us how many years. So log of 1.033 of 1.35. Double check that. Yep. And after 9.2 years, so it says what year, so this is going to be about 2009, because we started in 2000, so about 2009, since x is 9.2432, so 9 years, 2009. Okay, last one. The rate of decay of aspirin is 2.36% per minute. If you take 2 325 milligram tablets, how long does it take for half the aspirin to leave your system? All right, so half of 2 of these tablets is 325. 2 tablets, we'll add those together, we'll get 650. And it's decreasing by 2.36% per minute. So x is time in minutes. Okay, let's get the base and the exponent by itself. Let's divide by 650, and we know that's 0.5. Let's figure out what this percentage would be, or this decimal. 1 minus 0.0236. Okay. So that's still 97.64% still in your body after every minute. So 0.9764 to the x. All right, it's an exponential, so let's use a log to solve. Log base 0.9764, make your loop of 0.5 equals x. Type it in your calculator. Instead of typing in that 0.976, this right here, I'll use my last answer key. And then we'll type this in of 0.5. Oops. All right, so after 29 minutes, half the dosage is still left in your body. So for your assignment, you're just going to review how do you change things to exponential form, how do you change things to log form, and how to use logs to solve.